Today, I'll be showing you how to perform a Pi foundation design in Protastructure with the help of PileSoft software. We are going to use this software, PileSoft, for the design of Pi foundation in Protastructure. So you can see that this is PileSoft version 7. Basically, this is the latest version of PileSoft software, as you can see. So basically, this software helps for users to design perfectly a Pi foundation in the software Protastructure, knowing that Protastructure performs over design and most times on the design of your Pi cap or your Pi foundation on that. But with the help of these softwares, that issue is being resolved. Okay, and this software PileSoft works hand in hand with the software Protastructure. Okay, so for example, you can see now that these are the inputs you are going to input before you can design your Pi foundation, beginning from the shaft type, which is a Pi type, either rectangular, either circular or square, the Pi penetration, the Pi diameter, the Pi length, the column load, the direction of Pi, and the safe working load that you're going to get from your soil report, which I will show you just now. And then also for the type of your column, it is square, rectangular or circular and all that. And then for the concrete type, is it a normal concrete or a lead concrete? Okay, and then for the spacing and all that, and everything will carved, and then everything you then click on what design that sheet. It now give you the actual parameters you are going to use to now design for your Pi foundation in Protastructure. And also it also give you your drawing as your Pi appears here. Okay, that's fine. So back right now, let's now go and open up our soil report for the design of the Pi foundation. Okay, now on my right hand side now, you can now see that this is a sample of soil report and all that, and this is basically done for a Pi foundation. As you can see, it is for a deep foundation and all that. And this is a soil investigation report in Nigeria and all that. The state is Benin City, close to Lagos State, Nigeria. And then you can see the soil test for the Pi foundation, and the test actually was done at a depth of 24 meters, as you can see that. And if I go closer again below, you can see the borehole test here that was given here, as you can see that right now. But we are actually going to first bring out our parameters that we got from this place here into the Pi software here. So this is now the parameter we're going to work with. We are working with the 24 meters, as you can see that. Okay, so you can see that we'll have several depths and all that. So the first thing now I'll do here is to extract my safe working load here. So I can choose to use any of this diameter, but you have to first of all try your hands on the lowest diameter. But the most popular diameter of Pi is 450 and 600 for concrete buildings. Okay, for building structures and all that. So I'm gonna try 450 and all that. So with 450 now, if I pick 450, then now if I pick 450 now as my Pi cap diameter, I'll have to impute it here under PileSoft now as 450. I've already done this before, as you can see right now. I've already imputed all the values here and all that. So just now, this 450 you're seeing here is what I have here on my PileSoft here, as you can see it here, 450 and all that. And even I'm using 600. I'm to use 600, I would have picked 600 here and all that. But right now I'm to use 450 first and all that. So with that now, I will then go again now on my report here. I will then come again and choose my safe working load based on the Pi diameter which I have chosen. And the safe working load of 450 Pi is 740.10, and which I've already imputed here. And even I'm using 600 diameter of Pi, I would have used a safe working load of 1156.9. But I would choose this 600 if I'm getting higher number of Pis, or if 450 is not sufficient, I can then choose to 600. But for now, let's try 450 first as our Pi diameter for the design of the building. Okay, so right now I will take the safe working load of 740.1, which I've already imputed here also, 740.1. okay, that's fine. So once you have done all this right now, the rest parameters are to be gotten from the Protastructure, which is the column load, but this other one here is still gotten from the PileSoft, which is the which is the spacing factor. Basically, it is good to use 2.5 or 3.0, but I advise you do what, 2.5. That's fine. And then now you can now see here that says what, is your pile resting directly on the soil. Basically, it is good for your pile cap to rest directly on the soil, okay, because the soil helps to carry the weight also of the pile cap, okay. That's fine. But if it's not resting on the soil, then the values here will change, okay, which is the spacing between the pile cap and the pile itself will change. But I would say that it is resting directly on the soil, but that's the most common, okay. That's fine. This other one here is to be gotten after your designing of your pile cap. You will now check for the spacing between each of the piles and see if they are filling. If your spacing is too close, all right, you will not see it on the design and on the software that is failing, but PileSoft will tell you that your piles will like crack after the construction or during the construction. It will crack. Can you see that? That's what most software won't tell you and all that, but PileSoft will tell you what will happen when your piles are too close to each other, which I'll show you how to measure that later, okay. So I'll put him back now. Let me just say 1.5 and all that, okay, for now, okay. Then your cover, I will say 75 for my concrete cover, and then for my concrete grade, I'll just pick everything here as default. I will make a comprehensive video later, but for now I'll just show you how this PileSoft version 7 works perfectly. I'll then come now and do this, and then choose my concrete steel grade here for 410, okay, and then for here also 410 here for the main bar, and the main bar minimum I'll choose for Y16, and link bar for the links I'll choose what, the 10, okay, 10, sorry, just click here and choose 10. That's fine. And then once you're done with everything now, all right, I'll then come now and go and pick my column load from the software Protastructure, okay. That's fine. So from this place now, you can see that I've already done some designs on the pile caps, okay. You can see that for most of the columns, okay. But now I want to show you the how effective this PileSoft is when you're coming for your design of pile foundation using the software Protastructure, okay. Now I'll first of all go and turn off my grid lines because it's making it to look dirty, okay, and busy. I'll make it to do what, just to make it to do what, clean up the your view right now, correct. That's fine. So with this now, let me use this one now as a case study to design a combined pile cap for the wall, this wall, for this wall and for this column. Knowing that they are too close to each other, there is no way you can design them separately as a different pile cap. So you have to do what, combine them together as to one pile cap, okay. That's fine. So with this now, I'll then highlight this now, okay, highlight this, right click here and do what, say insert combine pile cap. I will show you for a single pile cap later, okay. That's fine. So with this now, I'll then minimize back into the software Protastructure. So back on this place now, okay, you can see that this software Protastructure is giving me that the number of piles that I'm to use to design for the for this magnitude of column load, that we have two walls and one column combining together on a pile cap is what, 3 number of piles, which is right, which is not done anywhere, because following the column load that you have here, if you divide this by the pile diameter, you'll be able to get your number of what, your number of what, your number of piles to use on that. But right now, let me just do that right now. So I will have to copy this load now into the PileSoft, okay. So this 3244.3 right now is the maximum column load when combining all the shear force and everything. So I'll choose this one now, which is the summation of the what, of all of them here, which is 3244.3, okay, into the PileSoft now. So I'll do what now, move to the PileSoft now. So on this place now, I'll then put in my what, my value 3244.3, okay. Let's confirm that again if that's true. Yes, that's true. 3244.3, that's true. So back now on our PileSoft now, since once you have inputted all the values now that you can see here and everything, you have meted your column load, you have put in your safe working load, you have put in your pile diameter, your penetration and everything. Choose everything correctly. Your pile length is 24, as you can see from our soil test here. The soil test here says that the safe working load for the both piles was gotten at 24 meters below ground. So this was the place where they got a suitable soil strata and all that. So let's begin from here to design to now assume what our pile length, which is what 24 meters. Okay, so we then put the value here from that here. That's fine. So then we now go, now once you have put all our values, now we then come here and then click on what design data what sheet. This PileSoft will give you all the parameters you are to use to perform your pile foundation design on the software Protastructure. Okay, so I will then come now and then click on this place that say what design what data sheet here. Okay, that's fine. So with this now, you can then see how that it is saying what it's saying that we should use what number of piles is what 8 number of piles, then use 110 or 1.2 or 1.3 as your pile cap depth and the pile size, so it will give you everything you need for your actual design of your pile cap and your pile foundation in Protastructure. Once you input your column load, safe working load, and that's all you need from the Protastructure, and you input all the things you got from your soil report into the PileSoft, it will generate all the input sheets, all the input values you have to use to design perfectly your pile foundation in Protastructure. Okay, that's fine. So right now, let's now go and input these values now into the software Protastructure. But before we go, if you want this software PileSoft, I would advise you purchase directly from the PileSoft company, or you purchase from us Ekidel, because we have direct link with the PileSoft company. So you can get the link directly from this video description. You can purchase it from there, and if you have any issue, we can be able to resolve it with you when using the software PileSoft. Okay, that's fine. And if you're having any issue purchasing the software, maybe challenges on that, you can also reach us on our WhatsApp platform, and we'll help to guide you on how to purchase that perfectly. Okay, that's fine. So with this now, let's now head on to the software Protastructure for to now input these our values for now to now get a perfect design. Okay, that's fine. Now, before we can now export these values now into the software Protastructure, we can choose to now print out this value, because we have already done for this particular column. So we can now go ahead now and then print out this value now by coming here and saying what print here. Now, once we print on this print button here, it will now direct us to convert this report now into PDF. Just hold on for that to now print out now. So we then come now on this place now, and now say where I want to save it. I want us to like save it on the place desktop here. I'll then put just save it like that, and then just put the file name and just say save here. Okay, it will now be on the now convert itself to what PDF. Okay, that's fine. So hold on now for it to now show on the PDF. Okay, that's fine. So with this now, you can then see now that our PileSoft now has now transferred all the reports into PDF format. So this is now the report here on the PDF here. So with this now, we can then now begin to now relate and transfer all our values that we have here into the software Protastructure. As you can see that this is now the value that we got from the PileSoft and all that. Okay, so we can then transfer this now, and even all the reports, as you can see, the drawings, everything here is just here. So we're gonna then now go and transfer this now into the software Protastructure. Okay, so let's now go and transfer this thing now to the software Protastructure. Okay, so right now we are now on the Protastructure interface now for the pile cap design, and then you can now see that they say from the PileSoft here, they say we should use what? We should use number of piles is what? 8. Okay, so let me just maximize this now. They say number of piles is what? 8. Okay, and then we should try depth of pile cap is what? 1 1 or 1 2 or 1 3. Okay, that's fine. So I'll then minimize this now and come here and change to what? Number of piles is what? 8. Okay, and then come here now and then come here and try 1100 first and see if it's okay. no, it's failing. I will then move on to trying of 1 2 because we have 3 values there to like try 1.1, 1.2 or 1.3. Okay, so I'll try 1.2 now, and that's okay, that's fine. I will then come and then impute the next thing now is to put in my pi diameter, penetration, and then choose this. So I will then go over to the PileSoft now to see the pi size and the penetration and the spacing factor. Okay, that's fine. Okay, now on this place now, let me just shift this a bit, okay, so that I can be able to relate that very fast. So with this now, you can see that number of pies now from the PileSoft is what, 8, which I have done here to be 8. Okay, 8 number of pies. And then from this place now that says what, use 1.1, 1.2 or 1.3 as your pi cap depth. We tried 1.1 before, it failed, but 1.2 is sufficient. Okay, that's fine. Then the pi diameter or the pi size is what, 450, which is already here, 450. That's fine. And then the next thing now is what, the spacing factor, which, okay, penetration is what, 75, which is here. That's okay. Then the factor for spacing is 2.5. Here I saying 3. I'll put here 2.5, and then here also 2.5. Okay, you can see that here right now it's now beginning to do what, fail. We'll then go and try the next depth of pi cap, which was 1.3, 1300, and then check if that's okay. That's fine, it has passed. And then right now then move on to the what, to the distance to what, to face, which they says here what distance to face is what, use 150, 200 or 250. So you can try any of these value, and that's okay. So right now come and try what, let me try 150, and then what here, 150 here. Okay, 150 here, that's fine. Okay, that's okay. And then come now and say what, ultimate compression capacity. Know that this cannot be gotten, you cannot get this if you don't have your safe working load from your soil test. Okay, now since we have our safe working load from our soil test, that we imputed before, that we imputed here on this place here, that will have our safe this place here, safe working load here, yes, here, this place here. And then when we now did design that sheet here, we now got this input sheet here. So we then do what, ultimate compression capacity is what, 1110.2. we then come here and put what, 1110.2, and then for the tension right now we have what, 370.1, 370.1, that's fine. And then the next thing now is what, is to do what, pi cap design is in direction 1. Okay, so come to this option here and make sure it is okay here, make sure it's in what, direction 1 here, direction 1. Okay, that's fine. Choose here direction 1 because that's what is here. Okay, then come back now to this other place here. Let me see, that's fine. Come back now again. The next thing is to do what, is now check for what, use internal bending radius of what, x is what, 64 or 130, and on y is what, 64. We can get this now from this place that says what, rebars here. Okay, that's fine. So on this rebars now, we then come here and put what, internal bending radius to be what. Now this can be gotten basically when you're choosing what, your diameter of bar. Know that we choose y16 from our PileSoft here. So we then come now and choose what, y16 here. Come here and choose bar to be what, y16, and then y16 here also, and y16. Now when you do this right now, try to make sure you confirm that it is not failing, and confirm that everything here is still okay and sufficient. Come here, everything okay, and then come to checks here right now, everything must be okay. Then come here and change your spacing. Right, let's try and use a similar spacing of let's say 200, and then here also 200. Let's see. Okay, let's try 250 if that will pass. 250 spacing, sorry, 250 spacing, and here also 250 spacing, here also 250 here, 250. Let's see. No, it's failing. Okay, it's failing already. Let's try 200. Let's see, and 202. Let's try that. Now it is passing, but you can see right now that it is too close. 1005 against what, 9 something is too close. So I'll try to use what, 175, and 175. That's fine. That at least we can have a better spacing here gap. Then for the sidebars, I can choose to use y12 for the sidebars, or let me still use y16. That's okay. That's okay, that's fine. So with this now, I will then come and put in these values right now. This part says what, internal at x is what, 64. I'll come here and put what, x here, which is the first one here, 64. okay, and the y, which is the last one here, is what? Sorry, x 64 and 64, okay, 64 here also, 64. The x right now has a maximum value of what? 130. I would advise you use what? 130, which is the maximum, okay, that's fine. And then make sure you come and check here that say design checks here, because most times this place can be showing successful here, while here on the checks here is failing. So make sure that this place is also passing, okay, and all that. That's fine. So with this now, we then come and do what? Now say okay here, okay now. So you can now see that basically from the onset, this software gave us what? Gave us the 3 number of pies only, and that, which was what? Under design. But with the help of PileSoft, we were able to do what? To now design this combined wall and column perfectly, and it got what? 8 number of pies. You can confirm it manually if you're good in manual design. Confirm manually and then see how that you also get this number of pies for your design, okay, that's fine. You already have all the values that I use for the design of this pie, following from the soil report, and then for the column load, okay, and then from the column load, okay, that's fine. So right now, for you to get this software, you can see how I have used to design and that. Now I will make a comprehensive video by the next video, which I'll upload tomorrow. You will see a comprehensive video of this PileSoft and how it will be used, okay, that's fine. So to get this PileSoft, check on the link down below and download the software. Note that if you purchase this PileSoft in another place, you might not be able to have a customer service after purchase. But if you purchase from Ekidel or from PileSoft directly, we can give you 100% customer service after purchase and guide you on how to use the software perfectly, okay, that's fine. So you can now see how we have used now to now design for the pie cap for each of the columns right now, okay, that's fine, which will also continue from on our next video to show you how to now design for other columns, okay, and okay, that's fine. So thank you so much and God bless you. We love you and bye for now. Now give this video a thumbs up and also subscribe to our channel Ekidel. We love you and bye for now.